In this problem, we're going to approximate the area of a region. The function f of x equals the square root of 16 minus x squared is defined on the interval 0 to 4. We want to graph the function f. We want to partition the interval 0 to 4 into 8 subintervals of equal length and choose u as the left endpoint at each subinterval. Then we'll use our partition to approximate the area under the graph of f and above the x-axis from x equal to 0 to x equal to 4. Then lastly, we'll find the exact area of the region and compare that value to the approximation from part B. We can graph the function in the usual manner by plotting points. If we do that, we'll get a graph that looks like this. Notice we've restricted our values for x from 0 to 4, and this is the graph of f of x equals the square root of 16 minus x squared. Now, for part B, we're asked to partition our interval from 0 to 4 into 8 subintervals. We want those to have equal length, so we'll use our formula b minus a divided by 8. This will give us 4 minus 0 divided by 8, which is equal to 1/2. So each of our subintervals will have a length of 1/2 unit. Since u is the left endpoint, we'll have a equals u sub 0, which is equal to 0. U sub 1 will be 1/2. U sub 2 is equal to 1. U sub 3 is equal to 3/2. U sub 4 is equal to 2. U sub 5 is equal to 5/2. U sub 6 is equal to 3. And U sub 7 is equal to 7/2. If we go back to our graph, we can see that with our partition, we're going to approximate the area underneath the graph of f and above the x-axis by using rectangles. We're going to use the left endpoint to determine how high our rectangle will go, and we'll have a common width of 1/2 unit for each of our 8 subintervals. We'll go ahead and draw in the 8 rectangles that we'll use. Again, using the left endpoint to determine our height. And we notice that each of the rectangles that we're using to approximate the area is larger than the region that's underneath the graph in that interval. So our approximation should actually overestimate the actual value. To find the area of a rectangle, it's length times width. The length is the height of the function on that interval, and the width will be a constant 1/2. So the formula for our area will be 1/2 times f of 0 plus f of 1/2 plus f of 1 plus f of 3/2 plus f of 2 plus f of 5/2 plus f of 3 and plus f of 7/2. This half comes from the width for each of our rectangles, and these are each the lengths for the respective subintervals. If we evaluate the function at each of these values for u, we'll have 1/2 times 4 plus 3.969 plus 3.873 plus 3.708 plus 3.464 plus 3.122 plus 2.646 and plus 1.936. If we simplify this, we'll get the area of our region is approximately 13.36 square units. In part C, we're asked to find the exact area of the region and then compare that exact value to the approximation we just obtained. If we look back at our graph, we would see that the region is actually a 1/4 circle We know that the area of a circle is pi r squared, so the area of our region will be 1/4 pi times the radius squared. In this particular case, our radius is 4 units, so the area of our region is exactly 1/4 pi times 4 squared, which is equal to 4 pi square units. Getting an approximate value for this, 4 pi is approximately 12.566. So the area, would say, is exactly 4 pi square units, which is roughly 12.566 square units.